Good morning everyone. Today I am going to discuss about the chapter 3 analysis and design of singly and doubly reinforced section. So first of all we discuss about the different design of concrete structure which we consider are the case of design. First one is working stress method, second one is the limit state method, then the third one is ultimate load method and probabilistic method of design. So normally in this four method we normally consider the working stress method and limit state method in this case, and basically the design we can consider by using the limit state method here for both singly and doubly reinforced section. In limit state method of design, the object of the design based on the limit state concept is to achieve an expectable probability that a structure will not become unsuitable in its lifetime for the use for which it is intended, that is, it will not reach a limit state. A structural appropriate degree of reliability should be able to withstand safely and all load conditions that are reliable to act on it throughout its life, and it should also satisfy the survivability requirements such as limitation on deflection and cracking provided in the above structure. It is the objective of design by limit state method. It should also be able to maintain the required structural integrity during and after accident such as fire, explosion, local failure. That is, limit state must be considered in design to ensure an adequate degree of safety and serviceability that must be required for a structure. And the most important of these limit state which must be examined in design are as follows. Limit state of collapse. For the limit state collapse normally designed on the base of flexure, compression, shear and torsion. This state corresponds to the maximum load carrying capacity, which is the most important thing for before we design any structure. We have to consider those things. And the first priority we provide for the structure to design, that is safety and serviceability. It is the most requirement for a structure. Then we are going to the type of reinforced concrete beam. Here the singly reinforced beam and doubly reinforced beam, both type of reinforced concrete beam available, and singly or doubly reinforced flange beam also available. So first of all we discuss about singly reinforced beam section. In singly reinforced simply supported beam or slab, reinforcing sill bar are placed near the bottom of the beam or slab where they are most effective in resisting the tensile stresses. Because in case of singly reinforced section, the bar provided in the tension zone, so that is the resisting of power of the tensile force is more, and here there is the reinforcement in simply supported beam is showing here. Here the section which is it is the tension zone, it is the compression zone, that is the breadth of the section, and from the top of the section to the center of the reinforced part, that is known as the effective depth, that is denoted as small d, and the capital D which is the overall depth of the section from top to bottom, and there is the cross section view of the beam section. Here steel reinforcement is provided and here tension reinforcement provided, and in the bottom part and the top part the compression reinforcement provided. Here two support is provided here. That is here wall support is provided in both sides of the beam. That is a clear span which lies between the two support. And here we discuss about the reinforcement in a cantilever beam, because the both simply supported and cantilever we used in the case of calculation of the singly reinforced beam section. So here we discuss about the cantilever beam also. So cantilever beam, here also the tension zone, the bar provided in tension zone, and the overall size of the beam is called capital D, and the center of the bar to the bottom of the section, that is known as small d. And here the reinforced bar provided, and that is a tension zone, that is a compression zone for the especially cantilever section, and that is also a support, and from the support to the end of the section, that is known as the clear cover, that is known as the effective span. Okay, then we are going to the next part. Here showing the stress strain curve for concrete. Here we use the stress strain curve for concrete, stress strain curve for steel we use. So first we discuss about stress strain curve of concrete. The stress strain which is showing, strain is showing in x-axis and the stress is showing in y-axis. In case of stress we define the FCK, and in case of strain we define the strain value of the concrete, and in case of stress we define the characteristic strength of concrete in case of stress strain curve of concrete. Here the percentage of strain is showing here, which is 0.20% and 0.35%, and it means 35%, and here the FCK line is showing here, and the curve is showing the stress strain diagram, the stress strain position of the concrete structure. Then we discuss about the stress strain curve for steel. The same thing here also, the stress strain curve in the case of concrete, the curve is lying in curve shape, but in case of steel the curve is lying in the straight shape. Here the strain is defined in x-axis and stress also defined in y-axis. The stress we define here, stress in steel and stress in concrete we also defined here, and the design curve which is the value is sigma y by 1.5, and the characteristic curve, that is a characteristic curve which is denoted in dotted line, that is denoted as sigma y, or which is the characteristic strength of steel, and here E is elasticity strength of is equal to 20,000 Newton per mm square. Here the curve showing the steel position in stress strain. Okay, the today time is over. In next class we discuss about the stress block parameter.